Okay, so we're up to video 36 for 105. This is going to be called the intermediate value theorem. All right, fancy name. It's not such a difficult concept, I think you'll agree. All right, so let's see. What's the story here? Intermediate value theorem. Okay, very fancy name. All right, this has to do with 3.2 still, and it still has to do with homework number 12. It's part of polynomial functions. Okay, so now let me just do a little intro here before I show you a problem. Polynomial functions, right? Polynomial functions look like this, right? They're waving around, Sometimes they go across, sometimes they go across this way, sometimes they touch and go back. Those are polynomial functions. That's how polynomial functions work. Now, what if I know a polynomial function is here for x equals 1, and I know the polynomial function is here when x equals 5, right? 1, and over here is 5. Then I know for sure that it must have crossed the x-axis. And I know that it's got at least 1 0. It might have crossed it several times, but I know at least once it crossed it. At least once the graph crossed x-axis. Crossed the x-axis. Again, if I know for sure it was here at x equals 1, right? And I know for sure it was here at x equals 5. At x equals 5. So somewhere along the line, it's got to cross it either several times or at least once to get from here to here. That's what this is going to be about. Very logical, pretty simple, straightforward. Problem number 1, f of x is equal to x to the 4th plus 6x to the 3rd minus 26x plus 15. Okay. Now, show that, here's how these problems are phrased. Show that this polynomial function, this one, has a 0. 0 meaning means you cross the x-axis. Has a 0 on the interval somewhere in between but somewhere in between 1 including 1 and 2 including 2. Okay, so method to answer this problem. As follows. Find f of 1, right? There's our polynomial, f of 1. Our polynomial is right over here. So, f of 1, stick a 1 into x for x to the 4th. Stick a 1 into x for 6x to the third. Stick a 1 into x for minus 26x, and then plus 15. Okay, what do you get if you do that? You get 1 plus 6. 1 to the third is 1, so 6, minus 26, plus 15. So that's 15 and 6 is 21. 22 minus 26 is equal to, you're going to get 15 is 21, that's 22. Sorry, it's going to be 22. 26 and minus 22 is 24. Minus wins, so you get minus 4. Okay, we're not done. Second, why am I trying to find 1? It's right over here. Now, second, find, you guessed it, f of, where are we? I'm sorry, 2, f of 2. So find f of 2 equals x to the fourth, right? X to the fourth, so it becomes 2 to the fourth, plus 6, 2 to the third, minus 26 times 2, plus 15 equals, okay, 2 to the fourth is 16. 2 to the third is 8. 6 times 8 is 48. Minus 26 times 2 is minus 52. Plus 15. How much is that equal to? 16 and 48 is 64. 64 and 15 is 79. Minus 52 is minus 27. It's positive 27. Okay. That means that that means that we can now show that there is a 0 between 1 and 2 on this polynomial. I'll tell you why. Because I know for sure that if f is 1, that if x is 1, then the y is equal to negative 4. So it's about over here. 1, 2, 3, 4. It's about over here. That's when it's 1. When it's 2, it's all the way up there at 27, right? When it becomes 2, 27. And over here, by 1, it is 1, negative 4. So if it's here at 1 and it's here at 2, it must have crossed at least once the x-axis. And therefore, we know that this function has at least 1 0 on the interval 1 to 2, etc. So we know it's there. And if it didn't pan out, then we would have to say we don't know. And that's it. Okay, that ends this video for the intermediate value theorem.